As we are aware that a large number of young individuals stay away from their home for higher education, jobs and other stuff, most of which are bachelors and stay alone and cook for themselves or depend on the mess for their breakfast. We often imagine how working individuals are busy in their hectic daily schedule. Meanwhile, they tend to get exhausted while returning from their jobs and end up buying online food, which is quite expensive or in some cases unhealthy too. Even we hostelers face same problem before entering our colleges. Same applies to abroad studying college students who have to either make their own food after returning from a tiresome day from their college or have to depend on mess for breakfast or brunch. Sometimes it looks cool, but it's unhealthy and costly to eat online food daily and even eating stale food over the mess. Hence, we came up with an ideation of automating this cooking process so that every individual can enjoy homemade food which will eventually be prepared by a robot in a hygienic surrounding. While considering this idea into a real-time application, we found it difficult to automate lengthy processes. Therefore, we thought of making an omelette at our initial stage. So here, as omelette cooking process is automated, thus we named our project as AUTOomelette. We mainly focused upon designing a system for cooking process absolutely without human interaction, though it was a difficult task and also quite expensive to implement. But we tried our best to build our prototype with least human interaction in the cooking process. Also, we got a platform to showcase and compete in this global event, which will give us a boom for future researches and development. We would like to thank Circuit Digest and Semicon Media for organizing this event for makers and innovators.
Let's start with the overview of system. The system comprises of two main sections. First is Robotic Arm, second is IoT part consisting of geolocation tracking. The schematic consists of Arduino Uno, 16-channel 12-bit I2C servo controller, ESP01 Wi-Fi module and 6 servo motors. For IoT section, we use most of the open source platforms such as Google Assistant, IFTTT and Adapter. While designing, we considered stepper motor as our first preference because the required torque was high, but these are quite bulky and robust, which results to huge cost of motors. Also, it was not possible to design an arm consisting of stepper motor with low budget. We selected 6 servo motors, from which 3 are of 20 kgcm and other 3 of 2.2 kgcm lifting capacity, which finally went fair in our budget.
At the beginning, we selected Arduino Uno as our main control board, but it was not feasible to control the position of arm in real time, which would also take large amount of time for programming the same. Thus, we changed to Arduino Uno based USB 18 servo controller, which also consists of onboard Atmega 280 chip with I2C interface for up to 18 servos. This board was easy to program with GUI for controlling each servo motor in real time, which eventually saved our time for programming. Also, an ESP8266 is interfaced with the controller board for communication with Adafruit Cloud.
The servo controller software is used to move a selected servo to a specific position according to the arrangement of elements required while preparing an omelette. After completing a single process, we exported the code and copied it to the IDE for carrying out minor changes in the code so that we could further make changes in the code as per our needs. Step by step, each generated code is then arranged as per our requirement in order to specify the sequence of whole cooking process in a single code. The final code with all the processes, sequence steps is uploaded to the controller using Arduino IDE and tested accordingly. We found lot of misalignments during this but managed it with few servo angle changes in the main program. The processes are then carried out by the controller according to the sequence of functions specified in the code. To make it interactive with humans, we added an extra circuit of audio record and playback. This circuit with APR 3383IC records 8 short audio tracks with interesting feature of playing back a specific track of your choice. Again, this sound record and playback circuit was interfaced with Arduino servo controller board to play a predefined recorded track as per our need. This module can also output predefined responses after a completion of specific step or cooking any dish. This makes the system more interactive with humans. The design was the main challenge in this project, hence we preferred SolidWorks software for the 3D model of ARM, which hardly took a week for making changes in the reference model. After designing all the 3D parts, we took a glance by assembling all the components in the right place. Then we placed our order with selection of ABS material to a local 3D printing service provider. Now we were ready with the 3D printed parts within a week and ready to urge up upon the program.
point we were ready with the program, the hardware assembly and the whole automated process of preparing an omelette from scratch. We didn't just stop here, rather than that we added some interesting feature based on IoT and geolocation in the system. So suppose you are at point A. B is the virtual circumference set in program. On map from distance from your home, which is point C, is approximately equal to time required for our prototype to complete the process of cooking an omelette. Suppose I am between any point between A and the circumference and gave a command as
prepare an omelette for me.
Okay, I will cook omelette for you till you reach home. Happy journey.
At this step, Google Assistant will send data to Adafruit server and will hold the data till I enter the circumference. As soon as I enter the specified circle, the command which is on hold will be sent over the servo controller board with the help of ESP8266 Wi-Fi, and the system will start making my omelette. The purpose behind doing this is that before I reach my home, my breakfast, which is a freshly prepared hot omelette, will be served, which barely requires manual efforts in executing the whole process. In short, the user can order food from the system while returning from home, and hot food will be ready when the consumer reaches the doorstep.
transaction is successful. Thank you for placing order on AUTOomelette. Have a good day. Your order has been prepared by our robot. Please wait for a while. Hope you enjoy the food prepared by me. Thank you. Hello, I am AUTOomelette. I am here to make food for you, my friend. Please select what do you want to eat today.
ah, ah.